Hi, I'm Curtis Brown, and I'm here with Robert Adut, my good friend who we're doing these smart space videos for you. This is the last one in the series. This time we're going to be introducing the idea of function notation. All right, so we're going to be exploring what does that mean, and we're going to continue to use that same context we've been using this whole time. So Robert, would you go ahead and get us started?
Yeah, happily, Kurt. Thanks for having me on. Rio, let's do.
Let's go.
Boom, boom. All right. So, brief reminder. In case I'm a glutton for self-punishment, I'm going to remind the world once again that my average daily phone intake is 3 solid hours. This is real
No
data
judgment here.
off of
No
my cell
judgment.
phone. Thank you. Yeah, if my eyes are glassy and watery, you know why. It's for reflecting over this moment. So if we're saying that this is a 3-hour average, we discussed that this is actually the slope of the line once it's graphed.
Mhm.
And so if we have this relationship of y equals 3x, where y represents the phone hours. This is hours phone. There we go, phone hours. And then this is the days of life that transpire. You know, days being 1, 2, 3, 4, 5. All right, a brief table just to back that up. You know, X is 1, 2, 3, 4. And then by using this particular relationship, when X is 1, we see that the phone hours is 3. When X is 2, we see the phone hours is 6, 9 hours, and 12. So actually, I'm going to bring this closer to the middle. You'll see why that helps. Okay, so come on with me. Very good. So here's the thing. You know, it's so much more palatable and understandable to say phone hours and things like hours spent on phone than it is to say why. And it sort of makes more sense to say days of my life or number of days passed since Monday or since the beginning of the year, right? And like we in the math world, for better or for worse, insist on using this y and x notation. Y, x, y measuring something, x measuring something. But fortunately, we can introduce this concept of not needing to use these fancy letters, variables, to measure what we're talking about. And we could actually create a relationship called, let's say, P. Okay, so let's call it P, why not? So P is the phone hours.
Yeah.
Phone
Like that.
hours. Okay, and now what's really fascinating about this is that we have to make a very important conclusion, probably the most inclusion that we offer the people watching this today, is that this idea of phone hours, these hours here, depends on how many days have passed. So in a sense, you could ask yourself a question. It's like, hey, you know, I'm on my phone for 3 hours a day, right? Let's say I burst into your home and I was like, hey, Kurt, I'm on my phone 3 hours a day. And
Wow.
you're like, cool, that's nice. Next time knock, but it's okay, we're cool. And I'm like, all right, I will. You sort of ruin the moment. But anyway, back to what I was saying was if I'm on my phone for 3 hours a day, so guess how many hours I'm on my phone? If I asked you, guess how many hours I'm on my phone, a question that you could counter ask would
How
be,
many days?
yeah, how many days are you talking? So what's interesting is if you really had to guess and drill down, you would say the first question is how many days? And then from days, you can decipher how many hours. So
Yeah.
the
Yeah.
hours depends on, the phone hours depends on the number of days we're talking. And
Yeah.
if the phone hours depends on the number of days we're talking, we could say that phone hours is a function of the number of days we're talking.
Yeah.
So
Yeah.
notice the purple. The idea is like earlier you treated it as like a vending machine. I'm gonna let you do that. I explained the vending machine metaphor. It was really nice. I always thought of it as just a machine in general. You know, I like the idea of a machine.
Yeah.
Phone
Yeah. Yeah.
hours, phone hours is a machine that goes like this. That's like, yo, I'll tell you how many hours you're on your phone. Just give me the number of days and I'll tell you whatever I'll tell you the hours. So
That's
what
it.
you can, yeah, I'll tell you. So let's say phone hours as a function of how many days, phone hours as a function of how many days. Let's even go like this, boom. So we can
Yes, I
make
love the
the,
parentheses there. That's a great reminder of the fact that I'm putting something into this
right,
this function. And I like your idea of like, hey, it's like, hey, give me how many
give me, yeah,
days?
give me the
How many
days, give me the
days?
days.
How
So
many
yeah, so
days?
I'm glad you brought that up. A lot of times students understandably confuse this idea of P times D. It looks like it would
Ah,
be P times D like this. It's not. We would call that, let's actually put it in here. Let's put it, phone hours is a function of the number of days.
that's how
It's a
you would
function,
read that P of
right?
D, right?
Yeah,
It's
and I'm
P
gonna put that
of
down.
D.
P of D
Hmm.
means phone hours based on the number of phone hours, let's say,
Sure.
the number of phone hours based on the number of days. Rocking. Okay. So let's make days whatever we want, my man. How about 10 days?
Okay. Yeah, I like 10. 10's a good
10 days.
bye-bye.
So 10 days, that would mean whatever, that means D is now plopped in as 10. So if D is 10, we have now concluded that we have 3 times 10, which is 30. So 10
We're
days, 30.
evaluating on that other side. We're evaluating
Right,
function at 10 days. We're actually saying, here's this expression, 3D, and that represents the number of phone hours that we're going to have. And 10 is the value we substitute in for D. So
right,
saying 3 times D, 3 times 10 is the evaluation. So P at 10 is 30.
right. So P at 10 days is 30 hours. That's the way to read this. This is
Wow.
the notation we're talking about. I know. Let's
Hey,
go
listen.
with a month. Let's go with a month, shall we?
Okay, so let's try a month.
I'm gonna avoid 30 days just because I like to keep the numbers different. So let's say the month of February,
Okay,
hypothetically.
20. Well, this year it was 29.
Let's do it. 29 days on the February leap year. So
All
that
right.
is P of 29 days. Let's fix that. 29 days. D is 29. So the machine is holding out its hand, like, just tell me the number of days and I'll give you the phone hours.
So
Tell
you
me the
tell it
number of days.
29,
29 times 3 is the same as 30
87.
times 3, 87.
I really appreciate, by the way, you giving me time to do the arithmetic.
Nice. Okay, thank you for that. 87 hours. So phone hours is a function of the number of days. Phone hours depends on the number of days. Can I throw it back to you and you can show us how that plays out on the graphing calculator?
For sure, for sure.
Okay.
Yeah, let
All
me
right.
share my screen here.
All right, take it back. Rocking. Okay.
All right, so now we're good to go. You can see my screen here.
Yeah.
So let's do this. Let's make that function that you had there. It was 3x, right? Or 3 times the number of days. Now,
Right.
the cool thing about this is we can actually rename this. So you said it was phone. Let's call it phone. Let's call it phone hours.
Yeah.
Okay. Phone hours of days, right? So the function phone hours of days is equal to 3 times the number of days. So we're going to plop that. We're going to plop that in there. Got this really nice picture here.
So what does X represent?
Graph. What?
What does X represent?
So X is the number of days. Now, I think about this as a vending machine myself. I love the idea of function machine, but I'm going to take it a step further. I'm going to say vending machine because I can totally relate to the idea of like inputting, pushing a button on the vending machine, right? And every time I push the button for my favorite candy, right? Every time I push the button, of course I have to put in a little money too, but every time I push that button, I'm going to get out the same piece of candy, right? I push in one button and I know exactly what's going to happen. For every input, there's exactly one output. So there's one and only one output. Now I could have multiple buttons that give me the same candy, right? I could have a function that gives me the same candy for every button, right? That'd be a really strange vending machine, but I've seen them before where it's like 12 buttons and it's all the same thing. That
Like soda does that. Yeah.
Soda
Yeah.
sometimes does that, right? But
Yeah.
like a candy vending machine, they might have 2 buttons for one type of candy and 2 buttons for another type, whatever. But if I push one of those buttons that is my favorite candy, I'm going to get that favorite candy. So that's how I think about this. All right. So now I can actually take that and I can do some things on this. I can actually trace. I can say, well, what is the value at say 2.5 or 25 days? That's off screen. Let's do 2 days. All right. So I had 2 days, right? And I had 6 hours. So when I input 2 into this function, I'm outputting 6 hours as the option. That's kind of cool on the graph. I think it's even more demonstrative or more relatable on a calculator. So I'm going to just plop in. I'm going to put in a calculator page really quickly, and we're going to do the same thing. We're going to call up phone hours. All right, we're going to call up that function phone hours, and into that function phone hours, I'm going to push the button that says 2 days. I'm going to push in that button that says 2 days. So
this is awesome.
That machine phone hours, that vending machine phone hours is going to operate on my input 2 hours or 2 days rather. And I'm going to output those 6 hours, right, for 2 days. So now the really fun thing is because we're on a calculator, we can find out all kinds of stuff, right?
Do it.
We can do some really fun things. Like let's say we do phone hours. Let's say we do phone hours of, I don't know, how many days are there in a year?
365, mind reader. Good job.
365. All right, so 365 days in a year is going to give the number of phone hours that we use through that year. All right. If we use our phone for an average, all right, so I'm going to just, because it's fun. All right, so 1095. All right, we're going to just divide that by 24 hours in a day, right? We're going to convert this from hours to the number of days per year.
Yeah.
So I'm going to just divide that by 24. So 45, a little bit more than 45 days out of the year totally spent on my phone. You know what's cool? We can go longer than that. So what if we did, I don't know, say how many years you might, let's say in 10 years.
10 years, yeah.
Can you make a prediction? Think about that for a second. If I do 10 years, that's 3,650 days, right?
Yeah.
So what do you expect?
Well, yeah, multiplying it by 10. So I already see the result of the previous line is by a factor of 10.
Yeah.
And oh, Lordy. Yeah.
We divide that by 24. Over a year. That's over a year that we spend on our phone.
Look at me. I'm so queasy right now. Yes, I gotta relax.
Insane, right? We can continue playing with this idea of phone hours being this function. And earlier, and Robert, I'm playing here. I'm going to take 1 more minute to play. Just bear with me for a second. So earlier we defined a function. We called it phone days, right?
Yeah, we did. Yeah.
We defined a function phone days, and we said that was 30, right?
Yeah.
For the number of days in a month times 3 hours per day.
Yep.
Right? Times the number of days.
Days,
right?
Good. Yes.
Okay, and we divide that by 24.
24,
okay?
Yeah.
Right? To kind of get this idea of phone days. Okay, 3 hours per day per month, right? So we're going to take that and plop that in there. Okay, so now we've defined a new function. We're going to call it phone days. All right, so let's find out how many phone days and just see if we were right. Okay, see if we were right. So
Oh, let's see if we're
days in a
right.
year.
I get it. I
All
get
right, so
it.
check
Good
this
job.
out. Phone days in a year. How many months are there in a year?
12.
There's 12, right?
This might be a little off because of the 30 days per month is not exactly
It's gonna
accurate,
be a
but
little
let's see.
off, right?
Yeah, yeah,
So
yeah.
we're not gonna be perfect, but we're
Yeah,
gonna
but it's good. It's good. A good
be
estimator.
really close. Oops, did I not do it right? I defined it. Phone day.
Phone days.
Oh, sorry. Let me do this again. This is why we do these things. So I did phone days with this great variable. I forgot to define it as a function. So I had to.
Right. Yeah.
Now,
Ah, done. Good job. Nice.
perfect. All right. So actually, that's a really nice demonstration. So check it out. Like I had to go back in and tell it what phone days was dependent upon, right?
Yeah.
I defined a variable, but that wasn't it. I wanted to make sure that I defined a function. So that function, phone days, is a function of that input x, which we reminded ourselves that that was going to be just days of the year, or sorry, in our case, months of the year, right? So we defined x as months of the year. So phone days of 12 months is 45 days
Yeah.
on the phone throughout the course of the year, which is crazy. Totally awesome though. Totally awesome that we're able to kind of figure these things out. So what if we do this a little bit longer? How many months in, say, I don't know, your life?
Oh, your life. Well, no. How about life
You-
since cell phone? Life since. Do like a 40-year span or something like that.
Okay, so okay, we'll do 40-year span. Okay, so 40-year span times 12 months, right?
Yeah. Yeah.
Right? So 480 months. Okay, so let's
Yeah.
just drop that in and just see what. Oh,
18.
1,800 days. 1,800 days.
Divide that by 365.
Years. What?
Divide that by 365.
Okay, so we'll
I
divide.
want to know how many years that is.
So almost 5 years. Remember, we're using an
Good.
approximation here, right? Because we're actually losing
Yeah.
a little bit of every year. So we're probably right at 5 years out of 40. I'm about to celebrate this birthday actually coming up. And so if I had been using my phone for 3 hours a day for my entire life, 5 years of it, 5 entire revolutions around the sun of constantly being on my phone.
24 hours a day. Yeah.
Wow.
Yeah.
Totally amazing.
Um,
Okay, so we got this idea of functions, like the idea that we can input a value into a function and output a function value, right? We're outputting a value from that function, phone days. All right, so really quickly, I want to we're about to wrap up. I want to see my lifetime. All right, I want to
that's
see
good. Okay.
so I'm planning on living probably longer than this, but let's just say,
Remember,
um,
this is like you didn't get your phone at birth, Holmes.
well, that's true. All right,
Yeah.
so maybe 80 years after I got my phone. Um,
Okay.
80 years
Okay.
after I got my phone. Wow, that would be a long time.
I think I'll name him Kurt, and he gets a flip phone.
Here's his phone. No, flip phones were not invented then. I'm sorry.
Okay. Right. Good.
Totally not happening. All right, so 3,600 days. 36.
Yeah, man.
Wow. All right,
Um.
so I'm gonna stop sharing because
Wait. Before you do,
I might get
go-
embarrassed.
before you do one more time, could you share it one
Oh,
more time?
I can.
Um. I just want to interject something that's really valuable to people. Just looking at Kurt operate with his screen here. Um, I would encourage anyone watching at some point in your life to take a programming class somehow, some way, because look at this type of power that he's demonstrating, this input output mechanism. It looks like the TI calculator here, the Inspire, is a great tool to introduce those concepts. But I think a programming class, you're getting into programming, and it just shows the sheer power of being able to create big data and manipulate data, so that you could create new understanding and new wisdom. So watching that is us really inspired to say that. So thanks for showing that. And
Yeah,
I
for
would just
sure.
recommend people to look into that at some point in their life, anywhere, just any sort of course online or whatever. to take a programming class.
Totally awesome thing to do. And yes, totally. I agree wholeheartedly that getting some computer programming is super, super valuable. And you can do that on the graphing calculator, which is also awesome. So yeah, definitely worth investing some time learning about that. So thank you for joining us for our introduction to functions. And thank you, Robert, again for hanging out with me and doing these Smart Space videos. I really appreciate it. It was a lot of fun. So we'll see you around.
Thanks for having me, man. Thank you.